Hey guys, welcome back. So here's what we have in store for us today. Summation notation. Why don't you guys put that down? Now we only have a few more lessons left to first semester. We have this week, I think we have one lesson next week. And then after that, it's just the final exam. I think that's what it is. I'll look over my calendar if that's not the case, but I think we're pretty much near the end here. So summation notation, and let me just explain what we're gonna do. You guys can go pencils down. So let's say that if I asked you to consider this series, 1 plus 2 plus 3 plus 4, all the way down to 20. If I asked you to copy that down, that'd take you guys like maybe a minute. It takes a long time to write down so many numbers. Is there a different way that we can write down so many numbers like that, but much faster? And this is not what I'm saying. I'm not talking about like 1 plus 2 plus ... to 20. Yeah, that's like an abbreviation. I'm talking about being able to write something like this down in a completely different format that requires less writing. And so for that, we introduced the idea of summation notation. So jot this down on your notes, and I'll explain how this works. So a given series can be expressed using summation notation as follows. So here is what we do. Anytime they ask you to write something down using summation notation, you automatically draw this symbol. And what we do is we create something that's called an index. And usually the letter from the alphabet that we choose is the letter N. And usually the index begins at 1. And the index usually finishes at some number. We don't know what it is. This is just a definition. So just call it K, something like that. And then what happens is, in here, we always write down our sequence A sub n. So let me put some labels so you guys can remember what means what. So this here and that there, that's the index. And this object here in the parentheses, that is the sequence that generates the terms in the series. So I'll explain what this means. I think we have 2 problems to do today. And they'll be identical in the idea that the goal is the same. But the numbers will, of course, be different. So let's make sense of this by trying some problems. Here we go. So problem number 1 looks like this. This one right here. Put this, if you would, on your notes. Rewrite using summation notation. Okay. Evaluate via Desmos. All right. So, rewrite using summation notation. So right away, without delay, I know that I'm going to need this symbol here. That represents summation notation. And let's see, so our index n equals 1. You always pretty much start it at 1. In more advanced math classes, maybe when you guys are in college or next year in pre-calc and in calculus, they'll start it at a different number. But for us here now, we'll start it at 1. Now, what number should I put up here? Here's how you can find out. This is A1. This is A2. Label them if you can. So, how many objects are we adding all together collectively? 1, 2, 3, 4, 5, 7 objects, which is why this is 7. So this is saying that we're going to add together, beginning with the first piece, all the way up to the 7th piece. Okay, now the only thing we need left is whatever goes in here. Now, what exactly goes in there? The sequence that creates these numbers is what belongs in here. So, in order to do that, let's go back in time 1 week ago today, when we introduced the idea of a sequence. So, time out. Recall, if you look through your notes, last week our arithmetic sequence was this one. Remember that? We had an equals a1 plus n minus 1 times d, where we know that the first term, a1, is 20. Okay. And we know that our common difference, well, look at the numbers. We're going from 20 to 26 to 32 and so on. What's happening as we go from one number to the next? In this case, they're getting bigger by 6. So 6 is your common difference. So really, our sequence has been activated. And here is what our sequence looks like. Isn't that right? We have a1 plus n minus 1 times d. So what I'd have you guys to do is take this pink, purple, maroon bubble, and the content within is what belongs in the parentheses. So copy and paste this material in here. So that says 20 plus n minus 1 times 6. So guys, we're done with the rewriting aspect. This is the exact same thing as that. So now if you want to know what this equals, we can go to Desmos and we can type in all that stuff there, and immediately Desmos will tell us the final answer. So let me erase the right-hand side of the board. And on your phones, guys, on your cell phones, on your computers, whatever, go to Desmos if you want to follow along. And let me show you how to type this in. So what you want to do on Desmos is, let me move it this way so you guys can see the board. Like that. I'll leave it right here. So in box number 1, I need you guys to create this symbol. And in order to create that symbol, type in the word sum. S-U-M. S-U-M. Type in sum. S-U-M. Boom, boom, boom. And boom, look, immediately without delay, the symbol pops up. Now just type in all of the pieces accordingly. From 1 to 7, 20 plus n minus 1 times 6. And if you guys notice, as soon as you type it in, Desmos is so fast. Here in the bottom right, final answer, 266. Just make sure you have all of your parentheses closed like that. Parenthesis, parenthesis, sequence, along with the correct index. So final answer to that would be 266. So let me get Desmos out of the way. Thank you, Desmos. You served your purpose. And box in, if you would, all of your final answer, which is both the summation notation and the value of it. So now you guys have 3 different ways of adding together lots of numbers that are arithmetic. What is one way of doing this problem? You can do this problem the way a first grader would do it. They would literally add these together one at a time on a calculator. That's one method. What's another method? You could use the series formula from last week. This one here. I totally could have used that formula to these numbers and have gotten the same answer. So that's the second technique. The third method for an arithmetic series is take the numbers, repackage them into summation notation, and then on Desmos, type that in to get your final answer. That's 3 different ways. So on your team test, or on your final, I should say, on your final, you guys can use any method that you want. It's totally up to you. All right, one more. Let's try this one, and then we're done for today. Let's try this problem here. And we'll use Desmos to help us out. So let's see. Maybe we can label the numbers. We know this is A1, A2, A3, A4. But you know what the problem is here, guys? I don't know who this is. I don't know if it's like the 10th term or the 1000th term. I have no idea where they are. And we have to find that, and we will eventually. For now, let's set up our summation notation. Okay, and let's go n equals 1, but I don't know what goes up here because I don't know how many numbers there are. I don't know who this is. So what we'll have to do is we'll have to go to our sequence to see who they are. So let's see. In here, we put our sequence. So let's find the sequence right now. Let's go to last week's material. An equals A1, n minus 1 times d. Where the first term, A1, is 8. And what is the common difference? To go from here to here to here to here, what's going on every time? You can see that we're subtracting 10 every time. So our sequence would say this here. That's our first term, and that's our common difference. So really, guys, this blue bubble, that sequence can get copied and pasted right there. So we'd have 8 plus n minus 1 times d. Okay. Now you guys can see we're pretty much done with this lesson, almost done with this lesson. We just need to know what this number is. So I have to find who this is. So you know how this is the last number being added? Since it's the last number, you guys can call it a sub n, because it's the last piece. And because you can call it a sub n, that number can be placed in here by substitution. And let's see what happens to this equation when this becomes negative 532. We have this equation here. Now let's run through this equation and let's solve for n. So let's subtract 8. These are gone. That's negative 540. And then you guys can divide by negative 10 because these are gone. And let me finish up here. So that's positive 54. And then you guys can add 1 to both sides of the equation to discover that n is 55. And n represented the position of that number here. So this last number is actually the 55th term in that series. And that's good for us, guys, because that means that up here, this is 55. And I think now we can go to Desmos to type this in to get our final answer. So let me erase this side of the board while you guys catch up. Let me erase, I guess, just the top part of it. And in the meantime, I'll go to Desmos and I'll type this in. So let's multitask. You guys catch up while I type this in for us so we can get our final answers. So we're going from 1 to 55, and it should be 8 plus n minus 1 times negative 10. And check it out. Desmos is saying, boom, right there, negative 14410. Negative 14410. So that is what, thank you, Desmos, that is what that series is equal to. And let's see, so we took that series, we found who this was, it was the 55th term. Desmos gave us the value of the series. Now let me say one more thing before I let you guys go. Let's box in our answer. So we wrote it in summation notation, and Desmos gave us this. Now here's the last thing I want to say. Don't copy, just watch. This is just a matter of interpretation. Like, for example, if you see this on an exam, what exactly does this mean? So this does not mean that we're adding 23 plus 24 plus 25 all the way to 45. Nuh-uh. What this is saying is we're adding together beginning at the 23rd term, whatever that is, all the way up to the 45th term, whatever that is. But for us, you guys are probably only going to see stuff that has a 1 up to whatever that is, where of course that number does not mean that the last number is 55. That means that the last number is the 55th term, whose value you'll probably be given. So try the homework, let me know if you have any questions, and I'll talk to you guys next time.